This is day 3 of related rates. This is 2003, James. Question 5. We can only do part A right now, but I want you to realize what you can do. Now, they do say, show that. They give you this because this answer will be used further in the problem. Okay, Casey? Zach? This answer will be used further in the problem. So let's say you do the problem and you can't get to that answer. Don't use your answer. Use their answer and go from there. That's why I have it up on the smartboard. So I'll read it to you. A coffee pot has the shape of a cylinder with radius 5 inches, as shown in the figure. Let h be the depth of the coffee pot, so they define the variable for you, where h is measured as a function of time, t is measured in seconds, and they don't even ask for units, which is really nice. The volume of the coffee pot is changing at a rate of negative 5 pi square root of h cubic inches per second. Because it's negative, what does that tell you? The volume is decreasing. So here's the formula, and we should do our find given whens. I'm going to pause the recording to give you a chance to do that. You'll be surprised at how many points you can earn on this problem. I'd like you to try it. Okay. We'll miss the lesson. Okay. From what I could see, you guys found out that you want to find DHCT. They told us that. And then you go up here. I have that highlighted. That's what you know. This is simply a formula. That's not given. That's just a formula. Now, you don't want you to get it wrong because you don't know the formula. What's the information that's given relative to this problem? What is this minus 5 pi square root of h? It's the rate of change of what? Volume as what changes? Time. Okay, you need to do the homework. Because if you do the homework, you'll find the find given whens in the homework, even if you have to use the answer key. No, there's no when, but that's okay. And you could write that, but you don't get a point for that. You can put it there, it doesn't matter, but this is where you get your first point. But a lot of you struggled with that. Remember, these are rates that are related. I need to relate what? The height to the volume. And I have too many variables in there. I want the volume and the height. But what's R? Does it ever change? No. Okay, so my volume equals pi times 5 squared times h. So what does that give me? Because I'd like to simplify. Anytime you're dealing with algebra, you don't want things complicated. You want to simplify. So volume equals what? 25 pi times h. Now what are you going to do? I need a DHCT and DVDT. So what do you have to do? What have we done in calculus all year? Found what? Derivatives. Now, can I pull that inside this constant? Yes. Continue. We're almost done. Okay, you guys, remember we have 500,000 exams to grade. And, you guys, 500,000 exams to grade. And we spend 8 hours, and we get an hour for lunch, and we get a little 15-minute break a couple times during the day. But when you are writing, make sure you're clear on what you're writing so that we don't mark it wrong because we just can't read it. About 8. Okay, so for 8 days. Oh, it's worse. And we love doing it. Yes. Okay. Okay, guys, let's get this done so we can get through a lot of problems. What's the VDT? Why do you think I wanted you to write it? First off, you got a point for that. So it's minus 5 pi square root of h equals 25 pi. Just substitute it in and solve. Okay, now what do? We divide by 25 pi. So I get, now this was in 2003. Okay, you guys in the back? And the chief reader changes every 3 years. Now, what they wanted to see, I'm not sure exactly, or would this only be 2 points in today's grading? I don't know. I took my exam in 1970, so do a Google search on AP Calculus in 1970. I got a 3, but you go look at the AP Calculus exam and see how hard it was. I think it's still hard. I got me my credit. I was fine. Okay, guys, you get 1 point for saying that. Well, that's the easiest point in the world. Then you get a point for finding dVdt. That wasn't even hard. And then you 1 point for getting from here to here. You know you have to get here. I think you could figure out a way to make it at least look like you know how you're getting there. Remember, James, the key word here is convince. You have to convince the reader that you know what you're doing. If there's any doubt, then we don't do it. Okay, let's get that yellow sheet out. And let's finish this off. And then we still have time for questions. Not really, but. Oh, that's okay. I probably have it open someplace. Now, we did this one yesterday. Okay, guys. You should have your yellow one out, but you may want a new piece of paper. And let's do this one. Now, you know what I'm going to do? I'm going to take a picture of this. It's the yellow one. And it's not drawn really the way it should be. Does anybody need a new one? Okay, shh. Guys. Jack. Okay. Now, I got to clarify this. Now, this is typed directly out of a book, so you can't blame me for the way it's phrased. Okay, you can blame me for the picture, though. It says a light in a lighthouse 1 kilometer offshore from a straight shoreline is rotating 2 revolutions per minute. Have you been up the Split Rock or any lighthouse? Yes. And at night, they're lighting the lighthouse. And that's the shoreline over there, my wall. Okay, guys? And the light is spinning around. So, guys, they're not going to understand the drawing. So the light is going down the shoreline, and then, of course, it goes around out to sea. I don't really want to do that. I'll get dizzy. And it goes down the shoreline again. Have you seen the old movies? Okay, guys? Casey? Have you seen the old? I have extra sheets. Have you seen the old movies with the prisoner of wars where the guys are trying to escape the prisons? And they always have the light going down the prison wall. Okay, that's the situation. So my picture isn't quite right. This is, I tried to put a lighthouse in here, but really what you are is you're up in a helicopter, you're looking down, you see the top of the lighthouse, and this is just a length of 1 kilometer. So the lighthouse is 1 kilometer from the shoreline. This is the sea. Okay? Okay. if you could take a picture of the light beam, you would see this distance here, and then at some point in time, the light beam will be here. And it's rotating around. So the light now is going to travel to here, and you're going to see that spot of light moving down the shoreline. And eventually it goes out to sea again. You're right, it's a circle, and then it comes back over here. Okay, so I want to get rid of all those lines. That's too many lines. Clicking the right thing. That should still work. You know what? Am I frozen? Okay. That didn't work either. Okay, so this is not the lighthouse. The lighthouse is you're looking down at the lighthouse. So the lighthouse is coming out of the board at you. We will neglect the height of the lighthouse. There is a homework problem that's similar to it. Okay, this light, we will take a picture of the light moving down the shoreline, but this length is changing. What would you like to call that length? L. I'm going to do L because that's what we have in the other class, and now everything matches, which is fine. Okay, there's some tricks to this. I have labeled things that are constant. The 1 kilometer is constant. That L is changing. Okay, guys, if you're not interested, I'm going to ask you to be quiet. Okay, the light's rotating at 2 revolutions per minute. That's what's what? It's given, isn't it? Okay, this is not working. Okay, it's 2 revolutions per minute. I'm not going to be able to pick up anything. What is that? Think for a second. It's rotating, Jack. It's the change of what? What part is changing here? The angle. It's like we're playing charades here. Okay. Okay. Well, guess what? I want that in radians. I don't want it in revolutions. Yay. Okay, guys. So we can get through this. Now, I want to change that to radians. Declan, how many radians in a revolution? A little more. 2 pi radians in 1 revolution. Or 2 pi radians in a circle. Okay, Colin? So this, what's d theta dt end up being? The revolutions cancel. How many radians? 2 times 2 is 4 pi. Because I have revolutions, and I don't want my angle in revolutions. Angle's a measure of radians, or degrees, either way. Then I have to worry about the units with the degrees. Okay. Now the next part. How fast is the beam moving along the shoreline? What do I want to find? How fast this is moving down the shoreline. D what? How fast? No. I want to know how fast this length is changing. It's the change in the length as time goes by. That's the velocity of that light beam going down the shoreline. VDT is a velocity. Okay. Now listen carefully. You have to read this carefully. Now, how fast is this beam moving when the light beam passes the point that's a half a kilometer from the point opposite the lighthouse? So let's start here. The point opposite the lighthouse is right here. Call it feet, whatever. So I want to know how fast is the beam moving when it passes the point that's half a kilometer. So this is 1 kilometer. I'll draw my little picture. And this is my point P. I want this distance to be half a kilometer from that point across from the lighthouse. Whoops. It does if you read it carefully. It says, it passes the point. No, it's a half a kilometer from this point that is opposite the lighthouse. It's half a kilometer away. Could it be on the other side? Yes. It's okay. We'll just take that. No, it's half a kilometer from this side or from that side, but the triangles are the same. They're congruent. So it doesn't make any difference. Yes. Okay. I know that's no, I mean, that's what it's saying, but you have to read it. Okay. Now, when you do related rates, this is the hard part. I want to relate L and theta. Okay, Jack? I need a relationship between L and theta. I know nothing, absolutely nothing about this side. So I don't want to use that side. What will relate this length with this angle, theta? It's got to be trig. Pythagorean theorem will work, but it's really hard. And it'll take you a long time. So it would be better to use trigonometry. And Jack said that the tangent of theta equals what? This length over that opposite over adjacent, over 1 kilometer. So I like the fact that it was 1. No, it's TOA. It's opposite over adjacent. You're looking at the wrong angle. Okay. That's the hard part. For right now, we are. Then after that, we're going to be going back to our regular book. Okay. How do I relate d theta dt, Declan, with the L dt? What do I have to do to my equation? Not yet. I got to do a derivative, right? Please stop me if you get confused. It's easier to do that than to go back and redo it. So I take the derivative with respect to time on both sides. Alexi, what's the derivative of the tangent function? You guys remember this one? It's secant squared. Now, that's the derivative of the tangent with respect to theta. But theta's changing, so then I have to use the chain rule. So it's times the change in the angle with respect to time. It's the chain rule, because this t does not match that. I could talk about how the angle changes with respect to the angle. I could do that, yes. But that's not what it's asking. So when I do the secant squared, that's the derivative of the tangent function with respect to theta. So I do d tangent of theta with respect to theta times d theta dt. And Alexi, what happens to the d thetas? They cancel there. Now I got the derivative of tangent with respect to time. That's the chain rule. We've been doing this for a long time now. That's equal to what? dl dt. Okay, I know what d theta dt is because I wrote it down. Do you guys remember? This. Because I wanted to take a relationship I had in my triangle that involved the 1 kilometer and the L, not the red segment because I know nothing about it. The derivative of tangent secant squared. Then I have to do the chain rule times the derivative of the inside function with respect to whatever that is. That's the d theta dt. I don't. I just did this because not everybody could see the chain rule. There. To the side. Yes. Yes. Okay, what's d theta dt, Brian? If you pay attention in class, that might be enough for those who don't like to do homework. But you better know how to do every single problem I've done. That's 4 pi. Okay, I want to find dl dt, so what do I have to do? I either have to find the angle or find the secant of my angle. So I'm going to draw my picture here. And it's not the scale. Just bear with me. This is 1, and that's 1/2. Can I find the secant of my angle? What do I need to know? I need to know the hypotenuse. True. You know what? I don't want to deal with fractions. You know what I'm going to do? I'm going to double my triangle. And here's where you really have to think a little bit. I don't even have to do that. Okay, watch. This is 1. This is square root of 5. Okay, this is going to be square root of 5 over 2. These triangles are similar. The ratio of the hypotenuse to that leg is the same no matter how big it is. What's the secant of this triangle, the red one? Square root of 5 over 2. What's the secant of this original one? Square root of 5 over 2 to what? 1. It's the same. I don't have to go back. Silly me, I forgot about that. So the secant is, now on the exam, I would not simplify. It's the square root of 5 over 2. What do I have to do to that? I have to do what to it? Square it. Times 4 pi. And so what do I get, James? No. Well, let's just do it. What's square root of 5 squared? 5. That's 5 over what? 2 squared is 4. But if you don't know for sure, this answer is just fine. That's equal to dl dt. What happens to the fourth? So the answer is 5 pi. Good. Mhm. Pay attention. It's a lot easier. Okay. Ready to go to the next one? We have one more of these, and then we're going to do your homework questions. And if you don't have them, I'll bring problems up. Now, let's see. I have a person standing on a cliff. Is that a cowgirl or a cowboy? You know, Mrs. Hersman I know, I have to zoom in. How do I do that? Okay, I'm going to have to take a picture, and it's not going to be very good, just to tell you the truth. I don't want that. Picture. Looks like a mustache to me.
She's got a mustache. It's a female mustache. Wait, girls can't get mustaches, Miss G? Is that what you're saying? Are you being biased?
Well, it's not all that common. You guys, the hard part about this is reading the problem and interpreting, which is why I say do the find, given, and when. Okay, so our cowboy is standing on a cliff watching a motorboat through a telescope. Shh, guys, Declan? The boat is approaching the shore directly below. It's supposed to be a her. It's him. But anyway, if the telescope is 250 feet above the water, we will neglect the height of the cow person. That's 250. Is that going to change? No. And the boat's approaching at 20. Shh, boat's approaching at 20 feet per second. Casey, what do you want to call this length? L. I would use X personally. That's okay. It says, at what rate is the angle of the telescope changing. Okay. No, the boat's sailing this way. What's going to happen to that angle? Changing, isn't it? Okay. What is it you want to find? There are no X's in our problem. No? Okay. Yeah, I want to find at what rate the angle's changing. So that's d theta dt. You have to read the problem. Okay, what is it I know? That the boat is approaching at 20 feet per second. What is that? Yeah, it's the change. Now the boat's not going on the hypotenuse, is it? It is dt. It's dl dt. I'm not asking that. It says what rate is the angle changing? Okay. Yes, check. Maybe. Yeah. Okay, ready? Nat, when's the wind? Oh, it's 250 feet from shore. So what's that? Okay. Now, what do you want to relate? See, these are those of you who like to memorize a procedure, this is one of the easiest things we can do. There's another thing that we can do, which we'll do next semester, and that I guarantee is on the exam. I want to rate theta and L. Theta and L. I don't want to use the hypotenuse because I know nothing about it. But I do know this. So you guys should know what to do. What relates theta, L, and 250? Okay, so tangent of theta is equal to what? L over, because this angle from the telescope's up here. You have to read the problem, over 250. Now, if you use the wrong angle, you will get most of your points. Now, to make this a little easier for you, and then I'm going to give you a chance to try it, but that's 1 over 250 times L. Is that okay? Okay, what do you have to do next? Find the... Because these are the same things, and this is a constant. I don't want to use the quotient rule because it's a lot of work. Just take the derivative. Okay, I'm going to give you a chance to try it. Then I have... Okay, Alexei, what did you get? We got to keep going. We're running out of time. Okay, guys. Declan, what'd you get here? Of theta. Don't forget the theta. Times what? Chain rule. Yes, you do. You're going to have a derivative on both sides always. Not that I want you to memorize that. Times dl dt. Now, do I know dl dt? Yes. dl dt was 20. So on this side, it's 20 over 250. And it's the theta dt times the secant of my angle squared. Well, we're going to go back to our triangle. And I'm going to redraw it. This was given at 250. They told me this length will be 250, and it's a special triangle. It's 45, 45, 90. Okay, Jack? So this side, if I wanted to reduce it, is 1, 1. What's this side? Square root of 2. This is square root of 2 times 250, but when you ratio it, what happens to the 250s? Cancel. So can't I just use this triangle? That'd be a lot easier. Square root of 2 over 1 is this. So that's 2 d theta dt equals 20 over 250. If you don't know how to handle dividing by 2 on a pre-response question, then just make it divided by 2. Yes? because it was given to me as the LDT. I just drew the triangle, and they said that was 250, and they said this is 250. No magic. It's at that instant. It's changing. It's not the same. It's not the same at different places. So I'm going to divide by 2. Now, if you don't know where the 2 goes here, then just do divided by 2, but I know it goes here. So it's 10 over 250 or 126. Don't ask me what I told you, Tyler. Okay. We don't have time to do a bunch of problems. Is there anybody here who has one in particular they want to look at? Do you want to do another angle problem? Would you like to do another angle problem or a cone problem? Or a bug on a parabola? I know that problem. What number is that? Oh, 17. Now, the other problems, shh, you guys, we didn't get as far because you were very chatty. Jack, McMillan. And we're not going to do those, but the other problems. We're going to do the bug on the parabola problem. But you can look at the smart boards for the other ones. This is 17. Now, for 5 minutes, can you guys be quiet? Shh. Let's try it. We have a bug walking on a parabola. I'm going to draw my parabola. I thought you said you guys could be quiet. See? Okay. And it says, at what point on the parabola are the x and y coordinates changing at the same rate? This is not a regular related rate, but it's pretty much the same. It says, at what point I want to find x and y such that I don't have a when. That's really what I'm trying to find. Such that the x and y coordinates are changing at the same rate. So what is the rate of change of x? Dx dt. And that has to equal what? The rate of change of the y coordinate, which is dy dt. That's the hard part, figuring that out. So then you go y equals x squared. I want to see how this is changing. I know I got a dx dt, dy dt. I think I'll just do the problem because I don't know what else to do. And you get what? Dy dt equals 2x dx dt. Now, Jack, Mank, if the x dt and dy dt are the same, what could I do to both sides? I could cancel these out because they're the same. What am I left with over here, though? 1. So what's x equal to? Because they told me they were. Yeah. It helps to read the problem. I read it. Yes? Yes.